Breaking news for travelers everywhere. Lux Search, the world's first AI travel search assistant, designed to plan and respond like a human travel concierge, has just launched. And today I'm pulling back the curtain on exactly how we built it, starting from the very end. Planning travel could be exhausting. Too many tabs open, conflicting prices, hidden fees, vague hotel descriptions, and those endless search rabbit holes. We wanted to remove that friction completely, and that's where our journey began. We followed Amazon's working backwards approach, the same customer first innovation method Amazon uses to launch its biggest products and services. Instead of starting with architectural considerations, code or wireframes, we began with a press release and an FAQ for a product that hadn't existed yet. Then we built toward that vision. We are bold enough to define what we believe could be our next $25,000 monthly recurring revenue opportunity. Here is the press release we wrote before a single architectural decision or even a single line of code. This forced us to think about customer value first. How will the experience be better? The headline read, Lux Search launches AI travel search assistant. Its key features had AI power planning, finding the perfect trip for your needs, as well as AI powered responses that provided chat clarifications and adapted instantly. The document became our North Star. Our FAQs helped us pressure test the concept. One big question we had was, how is this better than a regular travel site? The answer, Lux Search doesn't just list hotels. It chats with you, clarifies your preferences, and replans on the fly. Here is the architecture visualized in our diagram. As always, our design follows the AWS well-architected framework. We had a lot of considerations around cost, security, performance, efficiency, reliability, and operational excellence. A single web page app will run from the S3 bucket via CloudFront. The API gateway routes requests to our Lambda orchestrator, which provided the model context protocol server capability, while the MCP client was going to live on the front page. We had bedrock models, a responder model in cloud, and a planner model in Gemba Instruct. The models will be referenced using the invocation reference IDs, which is going to be stored in the SSM parameter. Parameter store. The hotel data is going to come from a third-party source, which is the Amadeus. We're going to be using the free tier in this instance. And we had to subscribe to get a secret key and an API key, which is stored essentially in the AWS Secret Manager. We're going to have a number of agents. We're going to have the hotel agents, and the budget agent. In this instance, we're simply going to be using workflow agents as opposed to these agents being fully autonomous. Think of the NCP server as a head concierge desk in a luxury hotel. When you make a request from your room, which is the front end, the concierge, the MCP server, doesn't personally carry out all the tasks. Instead, they know exactly which staff member to call: the chef for the room service, the driver for an airport pickup, or housekeeping for fresh towels. The MCP client, which is going to reside on the front end, is similar to a phone in your hotel room. It connects you directly to that concierge desk. The API gateway is the hotel's main switchboard, making sure that every call gets routed accordingly to the right place. MCP server serves as a future proof of our design to allow for secure and consistent external integrations. So when we open this up to third-party consumption, we'll offer it as a subscription service. If it stays in-house, that layer might not necessarily be needed. This is episode 0, the origin story of Lux Search. Next time in episode 1, we'll dive into the actual architecture build. If you love real-world cloud AI projects, hit the subscribe button and join us for the ride. Thank you.